All right, let's talk about the coldest place in the universe. And I'll tell you right now, the answer is definitely not what you're thinking.
So, let's start with a question that sounds simple, but it's really not. Can anything actually get colder than empty space? I mean, what could be colder than the void, right?
See, the thing is, the universe isn't actually at absolute zero. It's got a bit of leftover heat from the Big Bang. We call it the cosmic microwave background. Think of it like a faint, universe-wide hum of energy that warms everything up to about 2.73 Kelvin. That's the temperature floor. Nothing's supposed to get colder than that. Except there's a place that breaks the rule. There's a spot out there that's a mind-bogglingly cold 1 Kelvin. We're talking minus 272 Celsius, just 1 degree above the coldest anything can possibly be. This place is the Boomerang Nebula.
Okay, so how on Earth is that even possible? How can a chunk of a dying star be colder than the universe's own background heat? It just doesn't make sense. Let's dig in.
This thing is about 5,000 light-years away from us, and it is totally unique. I mean, it's the only natural object we've ever found that is so cold, it's actually sucking in heat from that faint Big Bang afterglow. That's the proof right there. It's colder than its entire environment. A total cosmic freak.
The best way to get your head around this is to stop thinking of it as just a cloud of gas. Think of it as a giant cosmic refrigerator. Seriously, that's not just a cute analogy, it's pretty much exactly what's happening.
So you can imagine the scientists scratching their heads, right? What in the universe could have enough power to chill the leftovers of a star to a temperature below the background temperature of space itself?
And the answer is a physics principle you've probably felt firsthand. It's called adiabatic expansion. You know when you use one of those compressed air cans to clean your keyboard and the can gets super cold? That's it. The gas inside is expanding so fast that it's using its own heat as fuel to push itself out, while the Boomerang Nebula is doing that same exact thing, just on a completely insane cosmic scale. And what's wild is just how much this whole process looks like your refrigerator at home. Your fridge uses electricity and a coolant to do its thing. The nebula, well, it uses the raw power of a stellar explosion to blast gas out into space. Different tools, same exact principle. You expand something really, really fast, and it gets really, really cold.
And when I say fast, I mean fast. The gas is shooting out at over 164 kilometers a second. That's almost 600,000 kilometers per hour. This star is losing mass 100 times faster than other stars like it. So this isn't just some gentle breeze, it's a cosmic superwind, and that's what makes it such an amazing cooling machine.
But here's the twist in the story. For years, everything we thought we knew about this place was based on an illusion. A beautiful one, for sure, but it sent us down a totally wrong path.
For decades, this is the picture we had. Hubble showed us this incredible, ghostly hourglass shape. You can see why they called it the boomerang, or a bow tie. It's gorgeous, right? And this image became the official story.
Turns out that picture was basically a lie. Or maybe not a lie, but it wasn't the whole truth. That famous shape we all knew, it wasn't really the nebula. It was just a trick of the light.
And this is why having different kinds of telescopes is so cool. Hubble sees the world in the same light we do, so it just saw the starlight bouncing off some dust, which made that hourglass shape. But then came the ALMA telescope. It sees in microwaves, so it could actually see the cold gas itself. And what it saw was totally different. It saw a huge round sphere.
So here's what was really going on. Imagine a thick, dusty belt cinched around the middle of that sphere. That dust is so thick it blocks all the light from the star in the center. The only places the light can escape are out the top and the bottom, like a flashlight with your hand wrapped around it. That's the hourglass we were seeing. Just two beams of light hitting the gas, while the real prize, the giant cold sphere, was sitting there in the dark the whole time.
Which brings us to the final and most explosive piece of the puzzle. What kind of event creates a massive, super-fast sphere of gas and a thick, dusty ring around the middle? Well, the answer is pure cosmic violence. Because a single star just dying on its own? It doesn't have the juice for this. It's not powerful enough. So what could possibly be strong enough to literally blow a star's entire atmosphere off at those kinds of speeds? The best theory we've got is something called a common envelope evolution. And that's a fancy way of saying it wasn't one star dying. It was two stars colliding, a violent merger. That is the engine we were looking for. Okay, so picture this. Step 1. You have a big star that swells up and literally swallows its smaller neighbor. Step 2. That smaller star gets caught in a death spiral, circling closer and closer to the big one's core.
Step 3, as it spirals in, it whips up the big star's atmosphere, transferring all of its orbital energy into that gas. And finally, Step 4, that energy builds up until, boom! The whole outer layer of the big star is violently ejected into space. That explosion is what created the superwind, and that is what's driving the cooling.
And the clues all point to this. The star left behind in the center, it's way too dim to be a normal dying star. The cloud of gas itself is super young, only about 1,500 years old, which tells us this was a sudden, violent event, not a slow death. And the chemicals in the gas? They show signs of being mixed together violently in a way that just wouldn't happen unless two stars smashed into each other.
So, mystery solved. A stellar merger created this cosmic refrigerator. But what does this bizarre, super cold object tell us about, the rest of the universe?
Well, here's the really wild part. This whole coldest place in the universe thing, it's temporary. It's just a phase. In a few thousand years, that little star in the middle is going to heat up like crazy. It'll start blasting out radiation that will light up that whole cloud of gas, turning this frozen ghost into a beautiful, glowing planetary nebula. It's going to go from 1 Kelvin to about 10,000 Kelvin.
And that leads to the final mind-bending idea here. Right now, the Boomerang Nebula is an anomaly, colder than the background heat of space. But the universe itself is still expanding, and as it expands, it cools down. Trillions of years from now, the entire cosmos will be colder than 1 Kelvin. So in a way, the Boomerang Nebula is just a sneak preview. It's a tiny glimpse of the cold, dark future waiting for the entire universe. Just think about that. You've got an object created by the death of stars that's temporarily colder than the leftover heat from the birth of the universe itself. It's just an amazing reminder that space is full of things that shouldn't be possible. And it really makes you wonder, if a dying star can break the fundamental temperature of the cosmos, what other impossible things are out there, just waiting for us to discover them?